Okay, so I believe we have almost full house, and I think only few participants are on the way maybe. So with this, with few announcement that let's talk about the food part. So for all the registered participants, we have arranged a breakfast kit which will be distributed after one talk, and then you have a lunch coupon. So our volunteers are there, so collect your lunch and breakfast kit basically. So now all of you got a kit, right? So there you will see there is a program. So you will follow this program. So you can all open that, just take it out, this schedule. So we will follow this schedule, but we may not be in time, plus minus 15 minutes. Okay. Most probably we will spill over. So this is the schedule we will follow. And in the kit, you can see that we have also the flyers for the 3 talks that we have today. So you can read who are the speakers. We have a brief bio sketch and what they are going to talk about. Okay. And then we have a poster for this IceCube event. And most importantly, all of you must have received this feedback form. Because as director said, like we are doing it for the first time for IceCube, we want your feedback. So you fill it whenever you get time, but please return it back in the evening when we will be distributing you the participation certificate. Okay. So you will bring this feedback form to the dais, hand over and take the participation certificate. Clear? And there are coupons also for the breakfast and for the lunch. Okay. And there is a nice write-up on neutrinos. Our director mentioned about some properties of neutrinos, their usefulness. So you can read it, okay? And the most important thing, you will see a magazine or a booklet. And I feel very happy. When we planned, we thought that whether we should be able to pull it out. But now it is there. So it is nicely arranged booklet. And here you can see our students' corner. What our students think about science. Okay. So please read it whenever you get time, or this kit will be with you. You are allowed to take it to your home. Okay. Share with your parents, share with your neighbors, share with your siblings, and propagate the message of science, the joyfulness of science among them. Okay. So with this, I would like to conclude the inaugural session, and now we will move to the scientific session. Thank you all.
Record this. Maybe I'm not record this mic.
So we will start our academic session, and whoever wants to attend this, most welcome. Okay. I again request, please come forward. Please come forward. There should not be any empty seat in the front. Yeah, because later on you will be able to talk to the speakers if you sit here in front of the in the front rows. So you have the schedule. So do you see the first lecture? I will be giving that lecture. Not lecture, I will just have a discussion with you. We will just have a conversation, okay? And there I will tell you some interesting things about neutrinos. But before I begin, I would like to urge all of you that I don't feel good when I only talk. So there is no barrier. You are here to learn. So in your classroom, you ask questions or not? You have to communicate, always say yes or no or something. You ask questions to your teachers? Be loud. I think only few of them ask questions. Say, yeah. So if you don't ask questions, then teachers don't know whether things are going in the right track. So same is applicable here. This is your school for today. And you are a scientist, I am a scientist. Okay? Let's make the equation very clear. So if you have doubt, if you have question, you should ask, you should get your doubts clear. Because of lack of time, sometimes all the questions will not be answered, but we are here during the break. Even if you go home, IOP is always here. You can come anytime and talk to us. Okay. So this is about the question answer. I already talked about the feedback form, and you have got the badge, right? So you are all IceCubers. अगर तुम लोग को पूछा जाए कि आज क्या हो तुम लोग, क्या हो? We are all. We are all good. Yes. So we are all IceCubers today, and you have received some postcards. Can you see in your kit? Huh? So this is first time we have come up with this idea, and throughout the day, whenever you get time, just look at those postcards. See what are the pictures are there, and at the back you will see some information. Huh? And this is for you. You will carry and you will share. कल जब अपनी स्कूलों में जाओगे, you are lucky because you are here, but you have other friends in your school. उनको दिखाओगे. Huh? It is your responsibility. I expect this from you. Huh? And you have stickers. For the first time you see in your kit. तो उसको अपने लैपटॉप पे, अपने स्टडी रूम में, अपने बैग पे जहां मर्जी चिपकाओगे, तो याद आएगा इस इवेंट के बारे में. ठीक है? पक्का? Okay, with these words, I will just start the academic session. So let me just move on. Because this week you can organize it. So, Gayatri, chair को हटा देते हैं. Krishna, switch on the light because some light is needed. It's too dark. Not this one, the other one. Yeah. What is that? Can you see the screen or some light? It is good because otherwise. Let's try once again. Slides are visible to you at the back now in this situation? Yes, sir. Because I don't see the face, then like, but you can try other, like here also lights are there. We just need one light. Can you try? Okay. Is it full screen? Okay, and you have started the Zoom and YouTube. Everything. Can you remove that bar? Okay, we are running behind the schedule by 15 minutes. But don't worry, it will be cut from your break. Not working. This is. So, okay, again, I would mention one thing, that don't get stressed out, okay? Just enjoy this event. Again, this is very important. And I forgot to mention that if you need, if you need something, volunteers are here, and the water is lying outside. Please keep yourself hydrated. It's peak summer. This is very important. We will be here till 7 o'clock. Now, I should mention. I can shout, yeah, like so. I would like to mention why we are keeping you here till 7 p.m. This must be a question, right? कहीं पर 7 बजे तक नहीं रखते हैं, 5 बजे छोड़ देते हैं. The problem is you will be talking to few scientists who are at the South Pole now, at the Antarctica, where our experimenters. And you know, South Pole में life easy नहीं है. You have 24/7 WhatsApp, Facebook, Twitter, Internet. वहां इंटरनेट कहाँ कब मिलता है, कैसे मिलता है, ये तुम लोग के लिए एक होमवर्क रहा. तुम लोग आज जाके खाली क्यूरियोसिटी के लिए सोचोगे कि साउथ पोल में जो बैठा है उनके पास कितना ब्रॉडबैंड होता होगा. हाउ डू दे गेट इंटरनेट? थिंक अबाउट इट. हाँ, मैं सब नहीं बताऊंगा, बट at 6:15 p.m. IST Indian Standard Time, for the first time today they will have the satellite to get the internet connection. So we are forced to keep you here till that time. Clear? Isn't it fascinating? So throughout the day, they only get internet for certain period of time. And during that time, they are collecting the data and they have to send the data to the people who are working on this experiment all over the globe, basically. So think about it. Maybe tomorrow you will be doing this job. Okay. So that's why 6:15 sharp they will connect and we will have a half an hour discussion with them. So before you listen to me, throughout the day, you make your questions ready because it is 30 minutes. वो डायलॉग याद है ना, चक दे इंडिया का, तुम्हारे पास 70 मिनट है, तो यहाँ पर you have only 30 minutes. तो 30 मिनट में you have to fulfill your curiosity. So write down your questions and all of you get your turn to ask your questions. But please make sure your questions should be to the point. You can ask कि तुम खाते क्या हो, कैसे रहते हो, पानी मिलता है, you have entertainment. If you have heart attack, what will you do? You can ask any sort of question because you need to know that what is the life at the South Pole. You have a booklet, right? Do you see that there is a column over there about life at the South Pole? Please read it. So you should be ready with your question answer when there will be a dialogue with them. So are you excited to be here till 6 p.m.? Yes, you will see. Huh? And you can ask, ठंड कितना है अभी वहां पर? Okay. So this is one thing. There will be 2 talks. The speaker are from Germany and they are the pioneers in this field. They agreed to talk to you today. There will be a question answer session again. So we will be having that session. I am encouraging you to ask questions. Once their talks are over, you can ask questions. When you ask question, you should first say your name, that I am blah from this school and this is my question. Okay? And there will be a microphone given to you. So don't just speak like that. A microphone will be given to you. You will speak loudly, clearly, because they have to listen through that laptop, right? Because they will be connected over Zoom. Clear? Equations are clear? Okay, good. So now let's start about these neutrinos. Krishnamurti, I am running late, so give me a little bit more time, okay? Gayatri, can I use this? No? Is it working? Hello? Am I audible? Okay. So today the name of the event is IceCube Masterclass at IOP. Huh? And why we need this experiment called IceCube? Ice का मतलब पता है क्या होता है? बर्फ घर में मिलता है, right? And cube, you know cube? Huh? 1 kilometer cube. You have an ice cube at home. So just go today and measure the size of the volume of that ice cube that you have in your ice tray. कभी किए हो? You are science student. No, that is a problem. You have a scale. Just go take an ice cube and measure it. What is the length, breadth, and height, right? And you get the volume. You know, I will assume that you know some sort of science, because you are from a very good school and you are almost quite mature kids basically. You are ready to go to college, except few of them. So think about that volume of ice cube that you have at home. And we are talking about a detector today, whole day. We are celebrating that detector is 1 kilometer cube. The length is 1 kilometer, breadth is 1 kilometer, and the height is 1 kilometer. So you just think about कि उतना बड़ा बर्फ अगर तुम्हें घर में लाना पड़े, can you keep it at your backyard? Yes or no? Please be loud with me, okay? So think about that. We are talking about such a big detector at the South Pole. The purpose of this experiment is, one of the main purposes is to detect neutrinos. So इसीलिए the title of my talk is Exciting Journey into the World of Invisible Neutrinos. In this talk, what you expect from me, mostly these two words. So I will set the stage. I will share some exciting things about neutrinos. And then in the remaining discussion, our team will tell you about the IceCube detector, the experiment, the data analysis that you are going to do, okay? So you have to be very attentive in all the sessions, correct? So today, let's first learn what are these neutrinos are, why they are interesting, and why we want to detect them with such a big detector. Make sense? Now, I told here invisible. So you must be curious, if something is invisible, how can we see them? Yes or no? So write down this question in your mind. By the end of this talk, you should be very clear about that. Why I call them invisible, but at the same time, we make them visible. How? With those detectors. Okay. So I'm just setting the stage. Clear? Okay. Let's move on. This is my, always I put this slide. This is my institute. You can see my office here. So we have a very nice office. And as I told you, I have an iMac, I have a MacBook Pro. So we are not, we are okay type. So you can become a scientist. And this is the auditorium we have. So these are the facilities. So today, if you get time, you can just roam around. वहाँ पर एक IOP, I love IOPB है. If you want to take selfies and all, fine. That's up to you. But when session is here, you should be here. Okay. So this is our IOP, and as our director told you, that last year we celebrated the Golden Jubilee. Okay, so we are going through a very nice phase. 50 years we completed this institute. And it is here, and you can come anytime. We are always here. If you come, nobody will stop you. You can come, you can use our facilities, and you can talk to any faculty member. Okay, that's why we are here. So, and this institute, we need money, and money is given by Department of Atomic Energy. DAE, ये नाम सुने होंगे तुम. They have many things in their agenda, but they support us. And just day before yesterday, we celebrated 40 years of DAE took over this institute. So at some point, DAE decided, okay, we will give you money. And that we completed 40 years, day before yesterday. And we had 1,000 students. We celebrated openly. Okay. So this is about our institute. We are here and most welcome. You can come and enjoy. So before I talk about neutrinos, I thought that I should start with a very basic question. So if you ask me, hey, what do you do? I say, okay, I study neutrinos. That is very narrow. But the bigger question that we ask here at IOP, some of my colleagues are also and our students, is this. So this is a very famous sculpture by Auguste Rodin. Okay, you will see it in Paris if you go in museum. And the title of, so this kind of statues are there. There are, more than one. There are several statues, but always the statue is like a man is thinking. So the title is The Thinker. So what is he thinking all about? The questions that he's thinking in his mind are the following. What is the world around us made of? So you see your universe, right? surroundings. So you should first ask, जब तुम गाड़ी में बैठते हो, ट्रेन में बैठते हो, सबसे पहले तो मेरा आस-पास में कौन है, right? So here also, like, you belong to this universe. So you should ask this question, and you always ask this question, that what is the world around us made of, or even we? Okay. What holds it together? Can we describe the world in terms of fundamental particles? So let me go inside. Think about this room. And you have to talk to me. Can you tell me what is the basic building block of this room? क्या है? Basic building block of this room. Brick. कभी ईटा देखे हो? हाँ, ईटा. Brick. And then you need to glue the brick together. Yes, great. So you use cement. देखो 9 का बच्चा, तुम लोग क्या कर रहे हो? So cement और बालू लगा के you glue the bricks, right? Similarly, we are not doing great. We are just asking the same question. That okay, this is a bigger picture. You see this room, you see the bricks, you see how they are glued because of cement and balu. Here we are asking the same question, but at the very deepest level. If I break you, like take anything, take this, take our body. If we break it and go to the tiniest level, what is the elementary particle we will see? That is a picture you have been taught in your school. But I'm telling you now, we need to go beyond that. Molecules, atoms, very good. Yeah, great. So atoms, you made my life easy. Atom tak tum log ko pata hai. So now we will go inside atom. And I will tell you that once you go inside atom, because we have instruments, we can go inside atom, and inside atom, you have some fundamental particles. Now, what is the meaning of the word fundamental? Because so far, uske andar hum nahi ja sake. Maybe tomorrow we have some very sharp instrument that I can see inside, but today, that is the end. So, like brick is the building block of this room. The building block of this universe. What are the fundamental particles with which everything in this universe is made of? That is the question. Clear? Huh? And then those fundamental particles we'll learn about, but you need to glue them, right? Because there has to be many particles together so that you can form an object, right? Think about, you have a cell. All of you are familiar with cell, right? You are the smartest kid of your school. So inside cell, molecules, atoms, then atoms, you have nucleus. And around that nucleus, you have electrons. Okay? If you are not on the same page, talk to me. So now we are talking about that system, nucleus, the electron, and then you can go inside the nucleus. Even there are fundamental particles. But you need something to glue them together. Okay? And there the fundamental forces come. Like inside nucleus, you have neutrons and protons. Now all the protons are positively charged particles, right? Right? Positively charged. Naam suna hai, protons are positively charged. Yes. Electrons are negatively charged. Now inside an atom or nucleus rather, you have many protons sitting together. Now you know that equal charges repel, right? Like charges repel. So have you asked this question? That inside the nucleus you have so many protons, but they are all happily staying together. तुम लोग तो दो बच्चे बगल में नहीं बैठ पाते हो, you always fight. Correct? Think about it. So many protons sitting inside the nucleus in such a tiny place. So there must be कोई glue तो चाहिए, right? कि उनको पकड़ के रख लेंगे कि no, they should not fall apart. There the force comes. Just an example, the strong force, the strong nuclear force is binding them together. So this is the message. What we do here at IOP, we want to learn about those fundamental particles with which everything in the universe is made up of. Correct? Clear? And once you know about the particles, you want to know how they are glued to each other. Means the fundamental forces. So we learned two things already. Okay, you can write, you have a note, or you can keep in mind. Fundamental particles, number one. Number two, fundamental forces. And while studying that, neutrino comes in the picture because neutrinos are also one of the fundamental particles. You can't break them. We have not seen anything inside that, but they exist as a fundamental object. Okay, but it is not, they are not there all. If you just take this object, they are not there. They are produced in some interaction. So you said beta, you said beta decay? That emitted. Okay, good. So yeah, okay, so we are on the same page. Good. So this is the purpose of this slide. This is what we study here. Let's move on. Just look at this picture for 30 seconds. I will not talk. Look at this picture. So you have this matter. You take a brick. So this is your brick. It's a macroscopic object, right? It's a big object. Size is big. When you go down further, you have this crystal inside, right? And the molecules. You see immediately the size becomes very small. 10 to the power minus 9. You have any idea how small is? 10 to the power minus 2 कितना होता है बोलो? 0.001, right? Can I have a chalk, Krishna? So this field is very important. So if you write 10 to the power minus 2, this is 0.01, right? 1 upon 100. And this size is 10 to the power minus 9. एक बार लिखो अपने नोटबुक में. 10 to the power minus 9 means 1 by how many zeros? Please write, feel it. That much meter is the size. So feel it. We are talking about that size. And that is only crystal. You go down, you have atom. So अब पता चला कि atom कितना छोटा है. 1 by 10 to the power 10. 10 zeros. So this much smaller thing we are talking about. Then you go down further, you told us that there is a nucleus, right? 4 orders of magnitude reduced further. And then you have nucleon. Nucleon means nucleus के अंदर जो neutron और proton है उसको क्या कहते हैं हम लोग? Nucleons. And then around the nucleons or nucleus you have electrons orbiting. Is this picture clear? Because if this is clear, I'm 25% I'm happy. And then in today's picture, we know that these nucleons are also not fundamental. So they are made up of something called quarks. Can you raise your hand if you have heard this word quarks before this date? Just raise your hand so that I know. Okay. So you are all have heard about quarks. Very good. So almost say 70% they know about quark. So that means inside nucleons you have quarks. And look at their size. Look at their size. 10 to the power minus 18, less than. इससे भी छोटा. And we are talking about neutrinos. We don't know the exact size of the neutrino, but it is way smaller than this, or of this sort. So first thing you should understand that we are talking about fundamental. Yeah.
So one thing and out there, showing that nucleon. Nucleon, we know there are 2 types, proton and neutron. The categories of shown there are in different colors that implies they are different. So what are?
Oh, okay. So can I answer this question after the talk? Because so they have a color quantum number, RBG, red, blue, green. Okay. So but those are high level things. let's talk about and we can discuss. Huh? Okay. Because for them it is not that important. That is a strong interaction. They are responsible. But yes, I agree with your question. Okay, so these are the nucleons, and inside these nucleons there are quarks, and they are colored objects basically. Okay, they have a color quantum number. So neutrinos, the particles that we are talking about are fundamental. You agree with me? And their size is very, very tiny. So we are talking about very tiny objects. Let's move on. So this is another view, the structure within the atom. We just talked about. So can you just take a look? Especially students, if you have any question on this slide. You are familiar, right? So this is the structure of the atom. You have this nucleus, and outside you have these electrons, right? Size of the electron is also less than 10 to the power minus 18 meter. And inside the nucleus, you have these nucleons, and inside nucleons, you have these quarks. So, sir, as you asked, so these nucleons, these neutron protons are made up of quarks, and these quarks carry color quantum number. Okay, and that's why they participate in the strong interaction. But in the break, I can explain you more if you are interested.
And moreover, just to identify between quarks, the
Right.
colors are there.
Right. So RBG, red, blue, green, we have 3 different colors basically. But it's just an abstract view that okay, they may have some in some space you can distinguish these 3 quarks. Okay. So you understand that? So we can talk about.
So what is U and D?
Huh?
What is U and D?
So U is the up quark, D is the down quark. So I will take you there. So when I say inside nucleons you have quarks, so they are made up of up quark and down quark. And why up and down depends on their spin. Okay, spin up, spin down. So up quark and down quark. Okay, so this is U for up, D for down. Clear? So now you can ask me, okay, we have this journey, right? From there, we reach there, but we need instruments. So these are the instruments. Just take a look. When you think about our galaxy, our planets, you have these satellites, right? But when you go down, suppose you have an animal there, you can see with your naked eye. But if you want to go farther, you want to see cell. So in your school, like there is a lab where you can see something, right? And then if you want to go inside cell, you have what? Molecules, atoms, nucleus, nucleon, quark. And you see them with this kind of machine. You have electron microscope to see electrons. And then once you want to go inside the nucleus, that means what you need to do? You need to send a messenger from outside that, okay, go inside and see, tell us what is there. For that, you need something called accelerators. And this is where the high energy particle physics comes. You need to create some beam of particles, very high energy, and you make it in your accelerator. There are big labs in US, in Europe, in UK. There are big labs where these facilities exist, and our students do work there. So in those labs, you create the beam of particles, and you say, okay, मैं तो नहीं जा सकता अंदर, तुम चले जाओ. So you shoot those particles, and they penetrate the nucleus, even inside, and they tell you, okay, this is what I see. Clear? I can't go because of time so deep, but you need some probe to send it inside, talk to them and tell you what lies there. Right? If you see an animal, or if you see your friend by naked eye, you can see this, right? But if you want to see inside nucleus, you can't see with your naked eye, right?
Because they're very small.
Yes, they are very small. So when you want to see smaller objects, you need a very powerful probe. You need to have something which are of very high energy, so that they can go deeper, right? If you want to go deep, you have to push hard, right? Correct? If you want to go and see what is inside this wall, you have to really push hard, break it and see inside. That means you need high energy. That's why high energy particle physics comes. Clear? Let's begin the neutrino journey. I am totally running out of time, but let's see. So this is a poem that I picked up to set the stage. So this is a poem written by this guy, Dylan Cassay. And if you are interested, just go to Google and type it. You will see this poem. This poem is all about his love towards neutrinos. So what he's telling, and I should read it because everything is in this one poem basically. Listen carefully. I go undetected. Problem. In all my interactions, I can't be seen. From any point of view, you won't know if I'm here. There are so many neutrinos in this room. You don't feel them, you don't know. Except when I'm gone, when they are gone, we see their signature. They leave some signature. That's what we would like to know today. I am the neutrino of love and I am coming over you. You can't keep me in a cage. Nothing can stop neutrinos. That's why, neutrinos can penetrate anything. And they can penetrate our Mother Earth and reach to you. No matter how thick the walls, I will escape. No matter. You just can think of this wall, right? But if you have millions of miles, a wall of lead, a neutrino can also penetrate. So they are very penetrating, nothing can stop them. Okay, so gradually we are learning about this particle, right? They are very, very tiny. Their masses are very low, I will tell, and they can penetrate anything, means they don't interact. You can't stop them. You can't hold me in a box, can't bind me with a lock, cannot keep me anyway. I am afraid of the dark. I am the neutrino of life. I am the neutrino of love. So you see, in this nice poem, Dylan basically summarized some neutrino characteristics. So I find this poem very interesting, very fascinating, especially when you talk to kids. And indeed, these neutrinos, what he wrote in the poem, they are elusive. If you can't detect them, they are elusive, right? They are mysterious, but yet abundant. In this universe, the most abundant particle is photon. Photon is what? The light, right? When you see a tree, basically the photons get radiated from that object and hits your retina, right? And then it sends the message to your brain that, okay, this is the picture of a tree, right? And the photon is the quanta for electromagnetic radiation, right? This is electromagnetic radiation. So in this universe, the most abundant particle, सबसे ज्यादा पार्टिकल मिलने वाले कौन है? फोटोन. और उसके बाद न्यूट्रिनो का नंबर आता है. Photon is totally massless, but now in recent years we know neutrinos have very, very tiny mass. I will talk about that number. So in the massive category, neutrino is the most abundant particle. इस पूरे ब्रह्मांड में न्यूट्रिनो की संख्या सबसे ज्यादा है. मतलब उसके लिए फिर जानना चाहिए, right? Understand? Interested? Good. So, like electrons, they are elementary particles. And Professor Frederick Reines, he won the Nobel Prize in 1995. I just found this quote from one book. The most tiny quantity of reality ever imagined by a human being. This was his quote. I can't imagine any particle smaller than this. This is the tiniest particle that I can ever imagine. Okay. This is another poem by John Updike. Okay, I will not go through that, but I just wanted to highlight. They are very small, no charge, no mass, do not interact. So these are so peculiar qualities, they are chargeless. Electron has charge, right? You all know. Can you raise your hand if you know that electrons are charged? They talk to electric magnetic field. Yeah, great, good. But neutrinos, they don't have any charge. So they can't talk to electric and magnetic field. So if they don't have any charge, you are the tiniest one, your mass is small, you are now getting the field. And if it penetrates everything, then how do you interact with it? How do you detect it? That's why I call it the first word in my title, invisible. Is this clear now? Why I call it invisible? No charge, mass is almost zero, tiniest particle, they penetrate everything, they weakly interact with the material, so that means they are almost invisible. But still we are talking about them because we have so many good experiments and we have detected those neutrinos. Let's see that. So these slides will be given to you in the WhatsApp channel that we have created, right? So you can take a look. So let me just go through this. Around 1900, there was a big problem. You must have heard that any process you consider in universe, in every process, energy and movement are concerned. Have you heard about this? फिर एक बार हाथ उठा दो तो मुझे confidence मिलेगा. Okay. So you agree with me. In all the processes, energy and momentum have to be conserved. So these two gentlemen, one is Professor Niels Bohr, another is Professor Wolfgang Pauli, two pioneers of this field. इनके चेहरे याद कर लो. You see, so they are discussing a famous problem. They were studying these neutrons. Can you tell me where the neutrons reside? We just talked about. कहाँ मिलता है neutrons? Nucleus के अंदर, nucleon, right? So they were studying that there are some elements. उसके अंदर जो nucleons है, neutrons हैं, neutrons they can decay. The neutrons can break to some other particle. You know, neutrons are inside the nucleus. They are studying this process. And according to the knowledge they had, they thought that it will go to a proton. Now, protons are also already there in the nucleus, right? And it will emit an electron. Okay? Now, you understand if the energy of this neutron, this is a fixed quantity, right? Because it is sitting inside the nucleus. So it has a fixed amount of energy. Now this proton is also at rest. It has a fixed amount of energy. तो ये इलेक्ट्रॉन का एनर्जी भी फिक्स होगा कि नहीं? A plus B equal to X. If A is fixed, B is fixed, then great. So here the energy of electron is energy of neutron minus energy of, and they are fixed. So if you do the experiment and you measure the energy of the electron, what do you expect? Great. उसका जितना इलेक्ट्रॉन निकलेगा सारे एनर्जी एक ही होंगे, राइट? समझ में आ रहा तुम लोग को? नहीं तो बोलोगे अभी, I can take the whole day. So this is what they expected. They did the experiment. They didn't see that. They saw that there are many electrons, but they have variable energy. Severe problem, right? आपको समझ आ रहा है? क्या नाम आपका? समझ आया क्या बोला मैंने? क्या प्रॉब्लम था? फिक्स्ड एनर्जी, पता है तुम्हें, फिक्स है.
That's why electrons should have fixed amount of energy when they're emitted, but they have variable energy.
No, the outgoing electron was having variable energy because neutron का energy fixed है, proton का fixed है, तो उसका सब difference लेंगे, तो आना चाहिए वो fixed होना चाहिए, but that was not the case. They saw many electrons, but they have different energy. That means energy and momentum, it seems like it is not conserved there, but you know that it has to be conserved. It was a huge crisis. Then Professor Pauli, he came up with a remedy. We can take questions after the talk, okay? Because I am running out of time. So he suggested there can be another particle जो तुम्हें दिखता नहीं है. It is invisible. And it is dicta means you can't see them in your experiment. That means they are neutral. They are very tiny. If they are big, massive, then you will see them. So there is another particle, and the energy is being shared by electron and that particle. You understand now? Neutron has a fixed energy, proton has a fixed energy. If you take the difference, neutrinos should have a fixed energy. But you saw that they have a variable energy. Means he suggested there can be another particle, and the sum of the energy of those two particles is always fixed. So think like you have another friend, and the energy of both of you is always fixed. Sometimes you are big more, you are less, he is less. So that means if I measure your energy, I will see a variable energy, right? Clear? So Pauli suggested that there must be a particle, neutral particle. It can cross anything, you don't see them, but it is there. And the energy is being shared by that electron and that neutrino. So he postulated that particle, but he wrote, I have done a terrible thing. Today I am postulating that there is a particle. I have postulated a particle that cannot be detected. In 1930, he mentioned that. But we are all lucky. We made him wrong. Basically, we proved him wrong. We have detected. So, who postulated neutrino? Great. When? You see, Krishna, they are on the rock. So, 1930, neutrinos were born through Pauli. But he said they will not be detected. We have detected them. Great. So let's move on. So this is the letter. He was a kind of a character. When the idea came in his mind, but that day he was to attend a function. So he didn't go to the conference, because there was a conference organized like this event, and all the people who are dealing with radioactive materials, they all gathered. He wrote a letter those days, because there was no WhatsApp, right? Twitter and all this. So he wrote a letter, and this is a letter. And this is kept in Zurich. I had the opportunity to go to Zurich, ETH Institute. This letter is kept there. I have seen it by my eyes. So if you become a scientist, you can also roam the world and you can see those. So in this, he wrote this letter, and this is in German, like you see. This is, dear radioactive ladies and gentlemen. This is the first line. So he wrote a letter that, look, today I have to attend a party. I can't go, but I am postulating that there is a particle who is sharing the energy with electron. So energy momentum conservation holds. Okay, so this was the famous letter. And in 1934, Professor Enrico Fermi gave the name neutrino. So Pauli didn't give the name. Pauli just told that there is a particle, it is neutral, but the name was given by Fermi in 1934, called neutrino. And it's in Italian word, it is a neutral little one, a small particle which is neutral. It's called neutrino character. Okay? So we know now something. So this is the standard model of particle physics. So I told you that we want to learn about elementary particles, right? So remember again this room, brick, cement or balloon. For us, the bricks are replaced by fundamental elementary particles, electrons, neutrinos, quarks, right? And the forces. So this chart summarizes that. Can you see neutrinos here? Any idea? कहाँ पर है neutrinos? बोलो बोलो ये वाले, right? So neutrino कैसे लिखते हैं? लिखो सब एक दिन पहली बार life in your life, write down new. That letter Greek. Huh? So this is, there is a notebook there. You have a notebook inside the kit, so you can write. So you see there are 3 different types. You will be hearing this today all day. So our goal is to study this bottom row, these neutrinos. We have 3 different type of neutrinos: electron neutrino, muon neutrino, tau neutrino. Clear? And you see with them, you have electron, muon and tau. So this is a family. Okay, this is called lepton family. You have heard about the word lepton, I know. 11th के book में है lepton. Yes, it is there. When you prepare for JE, it is there. So in the lepton family, you have neutrinos and their charge cousin. So I told you that neutrinos are neutral, right? But if neutrinos will come, and if somehow they interact with something, they will create their charge cousin. So if an electron neutrino is coming from somewhere, they will create electron. Electron is a charged particle or neutral particle? You agree with me? What is your name? हाँ, क्या नाम है तुम्हारा? मधुस्मिता. आपको पता है इलेक्ट्रॉन इज नेगेटिवली चार्ज. So charge particle को देखना आसान है, right? You have any idea how will you detect a charge particle? Yeah, have you heard about electric field, magnetic field? So charge particle will interact with them, right? Talk to them through electromagnetic force. Huh? So it is easy. But neutrinos, they don't have charge, Madhusmita, right? So you can't see them. So when they will come, they will create their charge cousin, and you will see them. Clear? समझ में आया? So these neutrinos, when they will come, they will interact, they will create their charge cousin, and you will see them in your detector. So you understand now? This is the way these invisible particles become visible. You know what I'm going to say? Good. So you see some of the properties I have listed, you don't need to worry about them. But there are 3 different types. They are abundant, right? And zero charge, I don't know whether you are familiar with spin, angular momentum. पता है ना थोड़ा? तो उनका spin half होता है. So they are in the fermions category. You don't need to worry about, okay? And only coupled to weak force. This is important. If they couple to weak force means they don't interact, they don't want to interact. Like a shy guy. Okay, किसी से बात नहीं करना, चुपचाप चले जाना. Okay, so neutrinos are like that. So you have to really work hard. तुम्हारा कोई दोस्त है अगर वो बात नहीं करता तो you really work hard to make him talk, right? Or hard talk, correct? So same thing. So you have to really work hard to make them talk, to detect them, because they only take part in weak interaction. So they don't interact, they just come and go. You remember the poem, right? Good. And now you see almost massless. This is a very important. I will spend 30 seconds. Mass, you know what is mass? Like you have the concept of mass.
Like weight or something?
Yeah, something. Fine. If you know that mass, weight, we don't distinguish now. So weight, right? Mera weight, I am a massive guy, right? 100 kg. So this is my weight. Okay, so you can say this is your mass, right? So think about electron. Electron कहाँ पर है? Nucleus के बाहर घूमता है, right? So see, you know. So electron, what is the mass? How much is the mass? Can you see the number? Something into 31 kg. So can you write down? This is a homework. Write down 10 to the power minus 31. कितने जीरो आएंगे? 1 by. So can you imagine such a small mass we are talking about? And these neutrinos, their mass is almost 1 million times smaller. Means 6 orders of magnitude even smaller. Minus 37. ये होमवर्क है, तुम लोग लिखोगे एक दिन तो आज करके जाओगे. तुम्हारे कॉपी में शाम को हम देखूंगा 1 by 37 zero, right? या फोन में कैलकुलेटर है तो just see we are talking about that mass. Don't you think it's a crazy thing? And we have detected with IceCube that my friends, my students are going to talk about. Okay, so these are very important. But Krishna, I will manage because I'm setting the stage, so you can just take some time out. So I just told you that these neutrinos, you don't see them like as it is. They come, if they interact, they will create their charge cousin. इलेक्ट्रॉन न्यूट्रिनो आएगा, इलेक्ट्रॉन बनेगा, उसको तुम देखोगे, फिर तुम इन्फर करोगे ना वो आया था। जैसे घर में एक ब्रेड रखा हुआ टेबल पर, ओके, और तुम आके देखती हो स्कूल से कि वो ब्रेड का गायब है, तो दैट मींस यू से कि मम्मी कोई तो आया था, राइट? सेम हियर। तो वो ब्रेड का गायब हो जाना इज इक्विवेलेंट टू किसी का आना। So here you just connect with your day-to-day life. So here, when you see an electron, it was not there. So something must have happened. And then these electrons, it was created by someone. And that was the neutrino. So this is a very, see, here you can see, oh, the door was closed, the key was only with my sister, so I key break khake chali gayi. Okay. But here the equation is very difficult. This is what they do. Here the students. To identify that, okay, I see an electron, but what is its source? This electron can come from anything. But I have to identify, now एक न्यूट्रिनो आके इलेक्ट्रॉन बना है. And believe me, मैं हंसते हंसते बहुत बड़ी बात कह गया. This is the most toughest problem we are facing. You have to identify something by seeing something. Because this electron in your detector can come from anything, right? But how do you know that this electron has come from this neutrino? From sun, from atmosphere, from earth, whatever. That is the toughest. Okay, let me proceed. So this is the journey, first electron 1930 Pauli proposed, 1934 उसका नामकरण हो गया, डेट सेरेमनी या कुछ भी बोलो, उसका हो गया, और 1956 22 साल बाद रुकना पड़ा. 1956, I will not go in detail, but these two gentlemen, they first time detected electron anti-neutrino in a reactor experiment. ये जो बिजली आप देख रहे हो ना, ये न्यूक्लियर रिएक्टर से आती है, पता है ना आपको? एक तो कोल जला के आती है, और नहीं तो कहां से मिलती है बिजली? हाइड्रो से भी मिलती है, पानी से, गुड. But you also get electricity from nuclear power plants, right? Green energy बोलते हैं उनको, right? नहीं तो you get it from coal or water. So whenever you have this nuclear power plant and you produce this electricity, there also beta decay happens, something. This neutron decays to proton, an electron and a neutrino. You have plenty of neutrinos and you call them reactor neutrinos. Come to here. So 1956, first electron neutrinos are discovered. Then 1962, Nobel Prize, 1988. Okay, in science, if you want to get Nobel Prize, you can get a Nobel Prize, but you have to really be lucky. And you have to wait. So you see, after 26 years, these gentlemen got the Nobel Prize for discovering muon neutrino. And tau neutrinos, right? By that time you are not born, right? So 2002, 2003, 4, like your birthday, 8. So just before that, tau neutrinos were discovered in 2000. Where in Fermilab, it is close to Chicago in US. Good. So this is the letter. This letter was written by these two gentlemen. The moment they discovered electron neutrino, they wrote a letter. And can you see, this is a telegram. This is the, have you written any postcard in your life, by the way? No, I believe. कभी postcard लिखे हो? 50 पैसे वाला जो पोस्ट ऑफिस से लाके लिखते हैं. आई थिंक आपके टीचर लोगों ने लिखा, आप तो लिखे हो सर, मैंने लिखा है, ये लोगों ने नहीं लिखा था अभी. तो पोस्ट कार्ड, but still available. It is abolished or it is there? There, right? So in those days, no communication, only letter. So he wrote a letter. Let me read. We are happy to inform you that we have definitely detected neutrinos. Baki ka rest of the story. So they wrote a letter to Pauli. Pauli, you said it will not be detected. We have detected neutrinos, definitely. So this is the letter. Pauli ka reply. That is even more interesting. Thanks for the message. He was an arrogant guy. Everything comes to whom who knows how to wait. So okay, fine. So this is a big message. it is true for your life. If you want to achieve something, you have to be patient, you have to keep working, someday you may get it. And that is an example. Huh? After how many years? 22 years it took. So this was the letter. So here, this is my almost, so in this slide, I am showing you where from you get the neutrinos. If you go out, please go out in the break, look at the sun. From sun, you get solar neutrinos. It is coming now. Okay, right? So it is called solar neutrinos, and I will just jump. So this is sun. So inside sun, so you know that sun shines in what? Light and energy, right? तुम्हें रोशनी मिलती है, तुम्हें धूप मिलती है, right? But ये जो धूप और रोशनी सन से तुम्हें मिलती है, उसके अंदर जो मेजर रिएक्शन हो रहा है, it's called fusion reaction. You have heard about that. सन के अंदर फ्यूजन रिएक्शन होता है. क्या होता है? 4 protons get fused together. 4 प्रोटॉन एक साथ फ्यूज हो जाते हैं. Okay, please pay attention. This is one of the major reactions happening all the time inside sun. 4 protons get clubbed together, and then this process happens. They emit electrons, they emit neutrinos also. अगर ये न्यूट्रिनो यहाँ नहीं होता, can you tell me कि क्या प्रॉब्लम होता? अभी मैंने आज स्टोरी में बताया. बोलो तुम.
Renewable energy show that there will be no conservation of energy.
Yes. You got the point. So if there would have been no neutrino here, in this process, energy momentum will not be. जो पाउली और बोर्ड डिस्कस कर रहे थे, राइट? तो ये इसको निकलना ही है. हाँ? तो यहाँ देखो सन के अंदर ये प्रोसेस से न्यूट्रिनोस आते हैं. Neutrinos are needed to conserve energy, momentum, and angular momentum. Okay, these are called solar neutrinos. So if there is no neutrino, no fusion, no heat, no light, क्या होगा? अगर सूरज नहीं निकलेगा, क्या होगा? Do we exist without sun? So today we go home and you say कि मम्मी पूछेगी क्या करके आओ सारा दिन? और मम्मी हम लोग अपने एग्जिस्टेंस के बारे में पढ़ के आए. ये जो रोशनी में धूप इतना काम करते हैं ना हम लोग, सारा दिन सूरज नहीं निकलेगा ये. So you understand, neutrinos are important for our existence. You agree with me or not? अगर न्यूट्रिनोस नहीं होते, ये प्रोसेस नहीं होता, तो सन शाइन भी नहीं करता लाइट और एनर्जी. तो इससे बड़ी बात क्या होती है कि एक दिन आईपी में जाके बिता ही सकते हैं. We exist because of sun. So sun will not shine without neutrinos. So if you go out and if you just look at the sun, you will see the solar neutrinos are coming, and they are coming in plenty. In plenty they are coming. Okay, you just need some machine. You wait for 10 years, 20 years, and you see some event. So sun से जो न्यूट्रिनो आते हैं, इलेक्ट्रॉन न्यूट्रिनो आते हैं. तुम्हें यहाँ पता है? देखो मैंने दिखाया था यहाँ पर स्टैंडर्ड मॉडल में क्या था. ये जो इलेक्ट्रॉन न्यूट्रिनो देखा, from sun we get electron neutrino. There are some process happens in our atmosphere also. These are called atmospheric neutrinos. And from atmosphere we get mostly muon neutrino and half of them also electron neutrino. So clear? I am not talking about artificial sources. तुम just बाहर जाओगे अभी ब्रेक में एक बार 1 मिनट के लिए, तुम्हें एटमॉस्फेयर दिखेगा. हमारे चारों तरफ एटमॉस्फेयर है कि नहीं? आपके चारों तरफ एटमॉस्फेयर है, राइट? कितना? 10-15 किलोमीटर. हमारे अर्थ के चारों तरफ, अर्थ इज अ प्लैनेट है, उसके चारों तरफ एटमॉस्फेयर है. 10-15 किलोमीटर में एटमॉस्फेयर है. वहां पर जो न्यूट्रिनो बनते हैं वो कहते हैं एटमॉस्फेरिक न्यूट्रिनो. तो you are getting atmospheric neutrinos right from your atmosphere, and they are coming to you. From sun you are getting solar neutrinos. So these are natural sources. You don't need to create them. They are coming to you. You just need a machine. Clear? So let's move on. So these are solar neutrinos. So you understood that neutrinos are essential for the sun to shine. आज घर जाओगे बोलोगे कि मम्मी हम लोग न्यूट्रिनो के लिए जीवित हैं. Okay, if you are convinced, and you explain your parents, you know कि आप ये सन का कितना महत्व है हमारे जीवन में, मगर सन के अंदर ये जो रोशनी ऊर्जा हमें मिलती है कहां से मिलती है, ये प्रोसेस नहीं लिख पाओगे अच्छी बात है, मगर बोलना कुछ फ्यूज होता है ना, उससे न्यूट्रिनो निकलता है, उसके बारे में पढ़ना है, ठीक है, कन्विंस्ड, हाँ ठीक है चलो, तो थोड़ा सा और, तो देयर आर मेनी वेज यू कैन गेट, दैट्स व्हाई आई रोट न्यूट्रिनोस आर omnipresent, यू गेट देम फ्रॉम योर अर्थ, अर्थ के अंदर जो रेडियोएक्टिव एलिमेंट्स है ना, हैव यू सीन मेंडलीज पीरियोडिक टेबल, सबने देखा है राइट, 7th 8th के बच्चों ने भी जाना, उसमें कभी नीचे देखे हो यूरेनियम, थोरियम, पोटेशियम, maybe you have seen towards the end in the periodic table, so they are heavy element, radioactive elements, means they are not stable, you have uranium, thorium, उसके अंदर जो न्यूट्रॉन्स है ना न्यूक्लियस के अंदर, they are not stable, they decay, and when they decay what will you get, neutrinos, right? I just wrote neutrons will decay to neutrinos, right? So in our earth, if you go inside earth, in the mantle, in the core, you have those radioactive elements, and they are all decaying all the time, and if they are decaying and neutrinos cannot be stopped, so जो neutrino तुम्हारे पास अभी आ रहे हैं, we call them geoneutrino, and for the first time 2002, it is not way back, just 20 years back, we discovered first time in Japan, they are called geoneutrinos. So you are listening today a very cutting edge research. It is not a very old fashioned research. Okay, so these are geoneutrinos. I will not go in detail, but there are many ways. But today you will hear from other people the IceCube experiment. Their goal is to detect neutrinos from very big objects, celestial objects, which are at the edge of our galaxy or even outer our galaxy, outside our galaxy. There can be supermassive black holes, there can be AGNs like active galactic nuclei, there can be gamma ray bursts. So think about, like, at the edge of our galaxy or outside our galaxy, there are big celestial bodies. They are bigger than sun, way bigger than sun. And some processes are happening, like in sun, there are also some processes happening, and they are emitting neutrinos. But those neutrinos are way high in energy. We have not been able to generate that energy in our lab so far. We are talking about such a high energy. And IceCube was built to catch those rare neutrinos. They are called astrophysical neutrinos. Please write down these words because they will be talking about IceCube. So what is the goal of IceCube? Why it was planned and designed and built? To catch, just write down 3 words: high energy astrophysical neutrinos. If you know about this, your life will be easy today. Okay? So there are massive bodies, massive means way massive than sun. वो हमारे गैलेक्सी में भी हो सकते हैं, गैलेक्सी हमारे गैलेक्सी के बाहर भी हो सकते हैं. ब्लैक होल का नाम सुना है? तो एक मैसिव ब्लैक होल कैन बी एन एग्जांपल. तो उसके अंदर कुछ प्रोसेस हो रहा है. We don't know, we have some idea. And through that process, these neutrinos are coming. So they are very far, right? This distance is very far and energy is very high. इसको कहते हैं high energy neutrino astronomy. A very well fashioned science these days. It is in news basically. Okay? It's called high energy neutrino astronomy. We want to detect those neutrinos because we want to know about those particles, those bodies. We can't reach to them, right? They are beyond our galaxy. They are so far. They are big. But we want to know their properties. How? When they are emitting neutrinos, if we detect those neutrinos, we can learn about it. Just an example. Director was telling in the morning, if you detect solar neutrinos, with some calculation, some research, you can tell what is the temperature at the center of the sun. Think about it. You don't have any direct probe, right? You can't go inside sun and measure. आपका तो measure कर लेंगे, सर का measure कर लेंगे, sun का कैसे करोगे? So there are ways. But by just detecting neutrinos जो sun के core से तुम्हारे पास आ रहे हैं, if you detect them, and then do some calculations, you can predict कि sun के center में कितना temperature है. You understand? So that's why they are the messenger of their mother soul. Okay, that means बच्चों को देख के पता चल जाता है कि घर में कैसे संस्कार दिए गए हैं. Right? So जो आप लोग हो, you are the flag bearers. No, आप अपने घर की धरोहर, घर के जो संस्कार है, you are carrying them. Right? Just by talking to the kids, we can understand what the atmosphere they are residing in, right? So similarly, life is science. You can connect whole day, all the events with science. By seeing you, I can understand what nature, what atmosphere you are in. So by seeing these neutrinos, you can really think about, what can be the environment inside their mother soul, from where they are created. You understand, right? Makes sense, no? So neutrinos are very useful to study about their mother sources. It can be sun, it can be atmosphere, it can be astrophysical bodies, it can be your earth, anything. So they are useful, correct? Okay. So just very fun facts, just few fun facts, because I am making their life easy. So this WhatsApp group में slide share कर दिया जाएगा, so you can just take a look. But to detect these neutrinos, people are very courageous. Human minds are excellent. We have done experiment in the South Pole, which you are going to learn. But now at same time, there is an experiment in the sea, in the ocean, in the Europe, in the Mediterranean Sea. A similar experiment is happening. It's called KM3 net. Okay, उसके बारे में I don't know whether they are going to talk about, but apart from IceCube, a similar experiment is called KM3 net. Recently, they are in the news. Just Google it. They discovered the highest energy neutrino ever detected. IceCube ने भी ऐसे इतना high energy का neutrino नहीं देखा. It is in Nature last month, Nature publication. Okay, this is called KM3 net. This detector is not in ice; it is in ocean. So human imagination. That's why you are here. People have gone to South Pole. People have gone to ocean. People have gone to underground. कुछ नहीं छोड़ा. To build detectors to catch these things. Okay. So see, your imagination can be, maybe tomorrow in Mars, you can do your experiment. I will not be surprised. You will be doing experiments in other planets. Okay. So think about that. Okay. So just one key. Now, if you think about your body, every second, 100 trillion neutrinos are passing. Please write down this number. Million, trillion सुना है ना सब तो डॉलर का अभी खेल है, right? So ये 100 trillion, how many zeros? So these many neutrinos are passing through your body right now, kids. And you don't feel. कुछ shake होता है? No, right? Simple. You see, these many neutrinos are passing through your body and you don't feel. Huh?
Feeling right now.
Yeah, right now. But do we have experiments? They do feel. Okay, there. So these many neutrinos are passing through our body every second. Imagine. But they are so weakly interacting, they don't harm you, but they pass through you. Okay? And you see sun, अभी बाहर जाओगे, sun को देखोगे, 10 to the power 38 neutrinos per second. I am dealing with numbers. 10 to the power 38, कितने जीरो होंगे? 38 जीरो. 2 मिनट लग जाएंगे 38 जीरो लिखते हुए. Those many neutrinos are if you go out, you will catch from sun. Huh? Fine. Let's move on. So very rarely interacting. I already talked about. They are very light. Already talked about. If you do your morning walk in the morning, we can still enjoy your work, and a neutrino must zip through this many people. एक न्यूट्रिनो को इतने लोगों के अंदर से जाना पड़ेगा, उसके बाद शायद वो डिटेक्ट हो पाए. You see, in fact, हमारे बॉडी के अंदर भी न्यूट्रिनो पैदा होता है, because we have potassium. And potassium, you see Mendeleev's table. Have you seen potassium in your Mendeleev's periodic table? किसने किसने देखा है? सबने देखा होगा. तुम हाथ नहीं उठा रहे हो? You have seen Mendeleev's periodic table? In which class you are in? 10. You have not seen Mendeleev's periodic table? तुम लोग को पढ़ाया गया है? Okay, so Mendeleev's periodic table is it tells you about all the elements. So there you see potassium. In our body we have potassium, right? Blood test जब होता है, those potassiums are also not stable. They decay. Through beta decay you get new. So मैं भी चलता फिरता न्यूट्रिनो सोर्स हूँ. मेरे अंदर ज्यादा है तो अंदर कम होगा. मगर we are all emitting neutrinos. In fact, you know, this is amazing. Neutrinos come from banana. Yeah, neutrinos come from banana. Banana emit about 1 million neutrinos. You know what? I see message to me when I did calculation. People ask me, I can calculate. So whatever tiny amount of potassium is there, potassium banana के अंदर रहता है, हाँ, थोड़ा सा भी जो भी है ना, वो potassium is radioactive, वो डीके करता है, तो सारे दिन में 1 million न्यूट्रॉन यहाँ पर बनाना रख दो, 50, it is a neutrino source. Fascinating, right? तो जो और उसको केला खाते भी हम लोग, कुछ नहीं होता, ठीक है? So amazing, हाँ ये, so okay fine, so ये solar neutrino एक experiment करके, they will talk about IceCube, but I am talking about one experiment. I am a big fan of it. It's called Super Kamiokande in Japan. Japan has done a lot of work in the field of neutrino. Okay, and I am lucky to see this neutrino by my eye when I went to Japan. So, what is this detector, by the way? A 50 kiloton water tank. ये बाहर जो जार है, ये पानी का बोतल कितने का? आधा लीटर का पानी का बोतल है ये, right? Yeah, 200. Think about, I am talking about 50 kiloton water एक टैंक में भर दिया. एक टन, मैं कह रहा हूं 50 किलोटन. ये नंबर तुम लोग को जानना पड़ेगा. You have to be ambitious. कि 1 किलोटन कितना होता है और 50 किलोटन, राइट? उतना वाटर को एक पानी में डाल दिए, एक टैंक में डाल के उसके अंदर सेंसर्स डाला दिए. उसको कहते हैं फोटो मल्टीप्लाई ट्यूब्स. ये जो छोटे छोटे डॉट देख रहे हो, ये बेसिकली एक पानी का टंक है, और बोट में देखो ये लोग घूम रहे हैं उस पानी के टंक के अंदर डिटेक्टर को ठीक करने के लिए. कुछ खराबी हुई है तो ठीक कर. This is the famous picture of the Super Kamiokande detector in Japan in Mozumi mine. I was lucky when I saw that field. Abhi, whenever I talk, I feel goosebumps. Okay, even if I die today, I will not have any regret. I have seen such a creation. Such a creation I have seen by my eyes. Okay, and now I'm working. So this is Super Kamiokande. 50 kiloton pure water in a tank. You see, in Japan, located underground, लोग जमीन के नीचे चले गए हैं, 1000 मीटर नीचे. मोजुमी माइन, उसके अंदर एक सिलिंड्रिकल टैंक के अंदर इतने लीटर. Just write down your notebook. I will wait. These many liters of water. हम लोग 1 लीटर एक दिन में पी जाते हैं, 2-3 लीटर. हाँ, कितने लीटर है देखो यहाँ. प्योर वाटर को इकट्ठा करके उसके अंदर सेंसर लगा दिया. And when solar neutrinos are coming, neutrinos are interacting in the water. It can interact anywhere, but you have such a big amount of water. Some neutrinos they are interacting. अच्छा ये बताओ, इलेक्ट्रॉन न्यूट्रिनो आता है ना सन से, मैंने बताया वो क्या बनाएगा वाटर में इंटरेक्ट करके? तेज बोलो. So you are all agreeing with me now. Electron neutrino will make electrons, or that electron will be sensed by these photosensors. You see all these dots ना, ये एक सेंसर है. It's called photomultiplier tube. और इसको बनाया है Hamamatsu कंपनी ने. Japan is famous for Hamamatsu. That is the company only making photomultiplier tubes in Japan. But now China is also making. Okay, so you see this, and how many PMTs? I think I have written some number. There are, you see, 11,146 sensors are there. This detector has won Nobel Prize in 2015. इसलिए, from this experiment, we got to know for the first time that ये जो neutrino है, they have some mass. Earlier we thought it is like photon. They are completely massless. But in 2015, Nobel Prize was given to Super Kamiokande experiment for the discovery कि न्यूट्रिनोज मासलेस नहीं है, उसका एक छोटा मास है. कितना छोटा आज याद है, अभी बताया मैंने. हाँ, you know number -31, -6, 37. Awesome, Krishna. She, just look at her. 10 to the power -37 kg. Yes, they have revealed that neutrinos have that mass. For that Nobel Prize was given. I'm glad you remember this number, 10 to the -37 kg. Great job. Okay, good. So, you see, he is the person, he detected supernova neutrinos in that same experiment, a little bit modified version. So, Nobel Prize was given, okay? So, what IceCube wants to do, now I will stop. I told you there are massive objects. It can be black holes. Can you see black holes? One example, there can be giant black holes. Some violent processes are happening. We want to study them, that what is happening inside, because they are the ultimate source of energy, right? But in that process, neutrinos are coming. You see, these neutrinos are coming and you are at Earth. Suppose this is your south pole and your detector is here. So IceCube is built to catch those high energy astrophysical neutrinos, which are very, very far. They are far, gigaparsec, megaparsec. By the way, have you heard about parsec? क्या है उसको बताओ तो.
Very large bit of this.
Great, you are close. That light travels how much in 1 light year? उसको हम लोग parsec, gigaparsec, megaparsec में parsec unit में express करते हैं, astronomical unit. So these, we are interested in neutrinos which are coming from our galaxy or outside our galaxy. This is the distance. Huge, humongous. You can't even imagine how far they are and what energies they are. So IceCube is built to see neutrinos from very far distant objects with very, very high energy. ये याद रखना. IceCube का काम है न्यूट्रिनो को देखना जो बहुत दूर से आ रहा है और बहुत एनर्जी लेके आ रहा है. High energy, high distance. Write down this word. Long distance rather and high energy. Okay, these are astrophysical neutrinos, and this is my last slide. This is your IceCube detector. So this is Antarctica. They will take over. So in the Antarctica, in the South Pole, this is we have drilled the ice, and we have put this detector. These are strings. This is your IceCube detector. सबको भूख लगी है? I will stop because they will take over from this. Your job is today to learn about this machine. Amazing machine. First of all, Antarctica जाना ही एक dream होता है. I could not go. I was in US. The hub of this experiment is in Madison, in Wisconsin, and I was there for 2 years with my daughter and family. 2022, 2024. Because of my high blood pressure and sugar, I could not go to South Pole. You guys can go. Definitely you guys can go, okay? If you work on this, if you are interested, you can sign up and you can be chosen. In summer, there are people, they go to Antarctica, do research for a few months. तुम IOP आ सकते हो, TIFR जा सकते हो, but what do you think मैं Antarctica भी जा सकता हूँ? You can go. There is a way out, okay? If you are interested, you just need to talk to right people. So people are there doing this science at Antarctica. आज सारा दिन इसके बारे में पढ़ोगे, जानोगे कि ये डिटेक्टर कैसे बना है, कैसे काम करता है और क्या-क्या इस डिटेक्टर ने हमें बताया है. Okay, so I want to stop, Krishna, too much time, but I think I made your life a little bit easy. So I would like to stop here. If there are any questions, I would like to take before we go for break. हाँ, वो बताओ question. Mike, better.
Mentioned in the super
I was not detailed, but yeah, बोलो.
in the super Kamiokande experiment,
बेटा ये super Kamiokande है.
Kamiokande.
हाँ.
So what they did is basically they saw they detected the electron which was produced from the electron neutrino, right? But you also said that it's difficult to depict if the electron has come from the electron neutrino earlier on. So how did it
Excellent question. Excellent question. Krishna, you see, they are ready to take over basically. You guys are in trouble. So, very good question. Let me explain this. Oh, sorry. Here is the SSID. You can write it in. So, what is your name? Anushka. Let's look at this picture. This is your water tank. ये handwriting drawing अच्छी नहीं है पानी है 50 किलोटन पानी लीटर हाँ 50 किलोटन वाटर इज देयर सुपर कम्योकंड हाँ सन यहाँ पर है यहाँ से न्यूट्रिनो आ रहा है हाँ तुम्हारा क्वेश्चन है कि इलेक्ट्रॉन तो बहुत जगह से आ सकता है कैसे पता चलेगा तो ये डिटेक्टर ना पॉइंट बैक कर सकता है सन तो बहुत सन इज अ पॉइंट ऑब्जेक्ट राइट जितना दूर चले जाओगे वो छोटा दिखेगा राइट तो फॉर सुपर कम्योकंडे सन इज लाइक अ पॉइंट लाइक ऑब्जेक्ट है ना तो वहां से जब इलेक्ट्रॉन न्यूट्रिनो आ रहा है तो मालूम करो ये इलेक्ट्रॉन आ न्यूट्रिनो आ रहा है पता चल रहा है ये आ रहा है व्हाट इज दिस न्यू ये पानी के अंदर आया यहां पर वो क्या बनाया इलेक्ट्रॉन बनाया राइट वो फिर इसके अंदर ट्रैवल करेगा एक रिंग बना के चेरेनकोव रिंग बना के तो जब मैं इस डायरेक्शन में मेरे सेंसर यहां लगे हुए हैं माय सेंसर्स आर हियर right they will see that light is coming from that direction so they will point back oh sun is there तो और जो डायरेक्शन से इलेक्ट्रॉन आ रहे हैं फिर वो सोलर न्यूट्रिनो नहीं है तो ये एक जरिया है by seeing the directionality you can point back to their source पता चला बेटा समझ में आया there are many ways many it's a very difficult question you have asked but you have the knack of becoming scientist. You ask the question which is pertinent. समझ में आया? तो हम लोग एक्सपेरिमेंट में इलेक्ट्रॉन देखते नहीं है, उसका डायरेक्शन भी देखते हैं, उसकी एनर्जी भी मेजर करते हैं. एक है एनर्जी, ये इलेक्ट्रॉन की एनर्जी कुछ एमईवी होती है और सोलर न्यूक्लियस की एनर्जी भी एमईवी में होती है. तो ये दोनों मिलना चाहिए ना. और बाकी जो इलेक्ट्रॉन है जो और डायरेक्शन से आ रहे हैं तो सन तो उधर नहीं है, तो वो तो सोलर न्यूट्रिनोज नहीं है और उनकी एनर्जी भी अलग होगी. तो बाय मेजरिंग द डायरेक्शन, राइट इट डाउन. ये जो पानी का डिटेक्टर है इसमें इलेक्ट्रॉन देखते हैं मगर इलेक्ट्रॉन का डायरेक्शन भी मेजर करते हैं और उसकी एनर्जी भी मेजर करते हैं. और जो सोलर न्यूट्रिनो है ना वो हाई एनर्जी में नहीं होता. एस्ट्रोफिजिकल न्यूट्रिनो जो मैंने कहा आइसक्यूब देखता है वो बहुत हाई एनर्जी में है मगर सोलर न्यूट्रिनो की एनर्जी काफी कम होती है. तो जब तुम्हें एनर्जी पता चल गई, डायरेक्शन पता चल गया तो तुम श्योर हो जाते हो कि बाकी सब एरे हैं वही सोलर न्यूट्रिनो. तो बाकी जो है ना वो नॉइज है. So these are photomultiplier tubes. So they are basically scintillating period, right? Photon detector. Right.
They are actually the photomultiplier tubes, but the light is actually coming from the Cherenkov radiation which produced in the water.
Water.
So
Or liquid. They are saying this is water, ma'am. This is so your medium can be scintillator. It can be water. So this your target is water, H2O. Your H2O and PMTs are basically an empty vessel. You have this photomultiplier tube. Right. That's it.
the PMT is from Hamamatsu.
Yeah, Hamamatsu. All questions. Questions.
Specific reason to use H2O only or just?
Oh, so this is one example. We can use iron. In India, we had a proposal कि हाँ 50 किलोटन आयरन को इकट्ठा करेंगे. Okay. So you can have iron, you can have liquid argon, you can have water. You know, you need huge amount. जो भी है, you need huge amount. Yeah, sure.
Yeah. Actually, he told that right now we discovered that the mass of neutrino cannot be negligible because it is there.
Yeah, we have detected that.
Yes, but according to the conservation principles, okay, before going to energy and momentum, we also have to conserve mass and charge.
Sure.
Charge zero, it is okay.
Right.
So, but when it comes to mass, when we take it as zero, then mass conservation holds there.
No. So good. So mass has to be conserved. You have some initial particle and then you have bunch of final state particles. जैसे न्यूट्रॉन decaying to प्रोटॉन, इलेक्ट्रॉन प्लस इलेक्ट्रॉन न्यूट्रिनो, इसका जो मास है इस तीनों का मास बराबर होगा if you add. So when earlier we said this mass is negligible, मेरे एक्सपेरिमेंट में इतनी ताकत नहीं है, it is not fine enough कि we can detect 10 to the power minus 37 kg mass. That is such a small number. अभी तक वो होना नहीं होना, if you do the measurement you will see इसका मास और इसका मास बराबर है, because whether it is there or not you don't. So there are other ways you see their mass. You understand? So there was always mass conservation, but it was apparent earlier. But now we know these neutrinos are also massive, but the mass is very, very tiny. You understand what I'm saying? So mass is always conserved. You have to take into account whatever the mass neutrinos have to match it. Otherwise, there will be some gap. But that gap is 10 to the power minus 37 kg. Very, very small. So that's why we never felt like that. Yeah, in that way, neutrinos ko to mass hona chahiye tha. But there are other ways. It's called neutrino oscillation. I could not. That's why we know that if something oscillates like pendulum, it should have a mass. Yeah, questions from students. Students, हाँ बोलो. क्या नाम है बेटा आपका? वैष्णवी. कौन सा स्कूल? क्या बताओ? क्वेश्चन बताओ.
We know that everything has its own advantages and disadvantages.
Say.
Can neutrinos be harmful in any way?
No. No, not at all. They are neutral. They are tiny. Your body now, you know, trillions of neutrinos passing through. तो कुछ हो रहा तुम? जिंदगी भर कुछ नहीं होगा. They are there. बस तुम्हें मशीन बनानी है, उनको देखना है. क्यों देखना है? उनके मदर सोर्स के बारे में जानना है. मगर they are not harmful. They are neutral particles. They don't radiate. Okay? Any question? हाँ बताओ.
I want to add on to the.
क्या नाम है आपका बेटा?
Diksha Priyadarshini,
Which school?
DAVCS.
चंद्रशेखर. हाँ बताओ.
I want to add on to the direction
Yeah.
part. So let's say we're talking about astrophysics, right?
Astrophysical neutrinos. Yes.
Right. So they're like super far away. We can like
Super far away. Yeah.
we can like pin it out like this. We pin it out sun.
No, but for if in this detector also, if there is any object very far, then it becomes point source for you, right? जितना दूर चले जाओगे वो point हो जाएगा. But they can be spreaded. They can be diffuse also. They are spreaded all around. But these supermassive black holes, if you see that black hole, which is like gigaparsec away from you, very far, not even in our galaxy, outer galaxy में कोई black hole है, और तुम यहाँ पर IceCube बैठे हो साउथ पोल में, तुम्हारे लिए तो ऑब्जेक्ट छोटा ही है ना, वो बड़ा होगा मगर बहुत दूर में है ना, तो वहां से अगर कोई न्यूट्रिनो आएगा तो उसकी भी डायरेक्शनलिटी, अगर वो बहुत एनर्जी लेके आ रहा है तो उसकी भी डायरेक्शनलिटी तुम
But it's
study.
hard to pinpoint the exact, like how will we know it is actually come from a black hole or like other celestial bodies?
Yeah, always this is a question. Yes, so we have a catalog. I told you these supermassive black holes, AGN, GRBs. तो हमारे पास एक कैटलॉग में बुकलेट दिया गया है. थ्रू रिसर्च हमारे पास एक कैटलॉग है ऑफ नॉन 110 सोर्सेज कि कहां ये सोर्स हो सकते हैं किस लोकेशन में. ये पहले से हमारी स्टडी की हुई है विद सम अनसर्टेनिटी. तो हम लोग को जब कुछ दिखता है ना तो हम लोग की डायरेक्शन को मैच करते हैं. अच्छा इससे मैच किया, इससे मैच किया, इससे मैच किया, उस कैटलॉग से मैचिंग करके वी कैन इन्फर कि हाँ ये जो इवेंट आया है उस सोर्स से आया. सो वी हैव अ कैटलॉग. समझ गए कि कहाँ वो सोर्स है, उसका लोकेशन कहाँ है, कितनी दूरी पे है. वी हैव सम आइडिया. तो अब हम हमारे डिटेक्टर में जब इवेंट देखेंगे we have to first identify कि हाँ वो उसी से आया है. So you can also use direction, you can also use energy. But yes, you are correct. Most of the time we are confused. Confused to say कि it is coming from that or it is coming from other.
Full linear.
Right? Yeah. If your event is happening and it is coming from some source there, maybe some other source is also in that direction. Yeah, it can be collinear, right? Same direction. Yeah, catalog is there. Definitely, you need some understanding where they are, and then you match. and you have, ML, this machine learning, so that you train your detector कि तुम्हें यहाँ से मिलेगा, तैयार रहो, और जब दिखता है तो then we connect.
What exactly do neutrinos speak? Like,
What neutrinos speak?
as in like, वहाँ पर कुछ हो रहा है, हमें कैसे पता चलता है कि वहाँ पर कुछ हो रहा है?
Okay, तो न्यूट्रिनोज आ रहे हैं, उनकी एनर्जी, उनकी डायरेक्शन और कितने न्यूट्रिनोज हमने देखा, उससे हमें एक कैलकुलेशन करके हम लोग उसके मदर सोर्स के बारे में पता कर, क्योंकि कितने न्यूट्रिनोज आ रहे हैं, कितना एनर्जी में आ रहे हैं, उनकी जो कैरेक्टरिस्टिक जो मेजर करेंगे ना, उससे हमें उनके मदर के बारे में.
But do neutrinos speak of like everything that's happening? Like, let's
Not everything, but at least you get a big picture. मैंने एग्जांपल दिया था, सोलर न्यूट्रिनो को देख के आप सन के अंदर का टेम्परेचर मेजर कर सकते, इससे बड़ी बात क्या है? हाँ बताओ, और क्वेश्चन है? हाँ अच्छा, हम लोग बाद में कब बात करें, बिकॉज वी नीड टू एंड, बिकॉज वी आर गोइंग फार एंड दे नीड टू टेक ओवर. We can you ask me this question in break? Okay, so Krishna, announcement, let's go outside. This is 11:55. We are way behind, but I ate their time. But come here in 20 minutes. Okay, you have a small packet, not heavy snack. Eat it, come back here. Okay, let's target in 15 minutes. We are back. Grab your packet, eat it there. Water is there. Let's come here around 12, 15 minutes. You need to show your coupon. Don't forget to bring your coupon, hand it over, and grab your breakfast packet or whatever snack packet. Hurry up, guys. Hurry up.
क्लास लेते हुए ले जाइएगा, है ना? हाँ, बाद में उसको कंपाइल करना.